Okay. Okay. I think we are live. So, hello everyone. This is Vedant and Orko. We will be your host and co-host for this session. So, as we all know, this session is going to be about chaos engineering in 2022, and this session is going will be presented by Saiyam Pathak. So, just a brief introduction about him. So he is working as a director of technical evangelism at Sivo with a focus on defining Sivo Cloud platform for simplifying Kubernetes and making it accessible for developers. Previously at Walmart Labs, Oracle and HP, he has also worked on many aspects of Kubernetes. And he also works on contributing to community by writing blogs and organizing local meetups for KTS and CNCF. So before moving further, in case you have any questions, you can always use session chats as well as we will be creating Slack threads for interacting with the speakers. We will be taking your session chats as well as in the Q&A sessions in the end. So yeah, so I think Sayam, you can start. The stage is yours. Thank you.
Awesome. Thank you. So let me share the screen. Cool. So hello everyone, and welcome to this particular session. Chaos Engineering 2022. Let's get started. So before that, a bit about myself. I'm working as a director of technical evangelism at CIVO. I'm a CNCF ambassador. I'm CKA, CKAD, CK certified, and also a KCNSB. You can follow me on Twitter at the Saiyam Pathak and tweet out anything that you learned from this particular session. Would highly appreciate that. So I also run my YouTube channel, so you can check that out. Latest and the greatest in cloud native tech, and there's a Discord if you kind of want to communicate with 500 plus people who are there with me on the Discord. And I'm also the author of the Kubernetes CK certification book. If you want to check that out. So let's get started with the chaos engineering. We are at Chaos Carnival, and it's all about chaos engineering. So it's interesting, and it's important that we define the chaos engineering in the right way. So there are a couple of things that we'll be many things that we'll be discussing today. What is chaos engineering? Then the principles of chaos engineering, cloud native chaos engineering, how the evolution has happened from traditional systems to the cloud native systems that are today. Then we look at a couple of tools like Litmus is there, and Chaos Mesh, and we'll go through the architectures and the workings, how they actually work, and then I'll show you both of the tools in action as well. So yeah, let's get started. So chaos engineering, to be honest, is not new. It came back in 2010 when Netflix introduced in I think one of the presentations Chaos Monkey. So the terminology is not new, the concepts are not new, the principles are not new. The only thing which is new is cloud native chaos engineering that has emerged in the past few years. Why? Because we will discuss about that. So Chaos Monkey was introduced by Netflix in 2010, and then many of the pioneers in the fields, many big companies, they came together, they defined they understood the concept of chaos engineering. Everybody started to practice chaos engineering. Obviously, it's like DevOps is the culture, so chaos engineering is also, you can say it as a part of the culture that is there. You have to adapt to chaos engineering, and you need that mindset of chaos engineering. So as per the principles of chaos.org, which is a website which everybody has kind of agreed to. So chaos engineering is a discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. So might sound fancy. What is the simpler meaning? Simpler meaning is you just are injecting a fault in the system to check whether the system is resilient or not. If it is, then the fault that you injected will not have any impact on the running systems, and means your system is very powerful. And what you do as part of chaos engineering is you try and try and try to fail that, so that you can find the bugs that can actually happen in production before they actually happen in production. So that's the kind of simpler definition I say for chaos engineering. Now, cloud native chaos engineering. Over the period of time, we have seen since 2010, if you say, there has been rise of cloud, there has been rise of containers, there has been rise of Kubernetes. So our systems have evolved. So we are no longer living in that single monolithic app domain. Now we have moved towards microservices architecture. We have more microservices. So let's go to the next slide. So traditional systems were very, monolithic kind of, where you have single input and the predictable kind of output. It's a linear approach that is there. And now the system is moving to cloud native meaning you have your bare metal or the servers or the virtual machines. On top of that, you'll be running containers. Now that containers obviously will be running in an orchestration engine, which is kind of the de facto, you can say, in today's world, Kubernetes. So you'll be having Kubernetes layer on top of that. Then you'll be having the cloud native components on top of them. So the number of microservices have increased. So you can see the architectural drift that has happened. So number of microservices have increased. The number of third party tooling on the ecosystem has increased. So for example, you install Kubernetes. On Kubernetes, you'll not just install your applications, you'll install many things. You'll install policies, you will install policy engines like OPA, Keverno, you will have your service meshes, you will have your observability tooling, you will be having storage. So all these layers will have its own components, and they also have to run perfectly if you need the best out of them. And then you have Kubernetes components. So Kubernetes itself is not just very simple. It's a kind of complex beast that is out there. So you have control plane components, and each component has to function well. If anything goes wrong, connectivity can be like API server, load on the API server, etcd, and all the components of the Kubernetes control plane has to be active. So, and on top of that, people are now moving towards more Kubernetes way. So you can imagine, like, the YAML stuff. So people wants everything to be in a declarative manner, so that they kind of get a similar feeling whenever they are deploying any of the applications. So they want a similar stuff. So why I'm telling this? Because traditionally chaos engineering was different. Now the chaos engineering have moved. The tools have evolved to a place where now it is more Kubernetes way, more cloud native way, built for microservices, withstanding the architectural changes that has occurred over the years. Um, the changing of deploying of microservices very fast, deploying the neo version very fast. So all these things are taken care. Let's go to the next slide. Now, in Kubernetes, how things works is, how people are thinking, and how things have evolved is, so you have single source of truth, which is Git. So now everything we want is GitOps. GitOps, another fancy word. We will not go into that completely, but it simply means that your everything, a single source of truth is Git. Everything you store is in Git. You want to store the state of your chaos experiments and works in Git, and that is where you need a single source of truth. Now you will be having a cluster. So you are having your Kubernetes cluster. In Kubernetes cluster, now Kubernetes has a concept of custom resources. For example, I can create a kind Saiyam in Kubernetes by writing a controller for that. So it's more of the operators and the controllers that the projects have evolved to, so that the operator can work in a similar manner like the Kubernetes control plane components. Watch for the custom resources which are written in YAML files, and perform the chaos experiments. It is similar to, like, you are creating a pod, it is going to the API server because it's a Kubernetes component and API server already knows, and then all the process follows and the pod is deployed. For the custom resources, like for the chaos, you'll be having a custom operator that will be deployed onto the cluster, that will be part of the installation. And then you have the custom resource. You have the YAML file that you'll be writing, or you'll be interacting via the UI. Internally, it is a YAML, then converted to JSON and stuff like that. And it will be deployed as pod. So that is why this is the cloud native way. This is the cloud native way that is happening. Now, earlier, obviously, it was not happening like this. The chaos was not happening like this. Now it is happening in a more cloud native way. So I hope you got a gist of from where we have evolved. What is chaos engineering? So by now, two questions are clear: what is chaos engineering, and what is cloud native chaos engineering? Why the shift has happened, and how the shift has happened from traditional to the new systems, and what the new kind of chaos engineering looks like. But the principle of chaos engineering still remains the same, because we are only changing the methodologies, but the principle remains the same. The concepts of chaos engineering, the mindset of what we actually want to achieve using doing chaos engineering has is still the same. So the principle of chaos engineering is, first we define the steady state. So steady state is the measurable output under control conditions. So you define what your steady state looks like for a particular microservice or application. Then you define the hypothesis. You define the hypothesis. Our steady state will persist no matter what change we want to do on top of that um, steady state. So we will introduce chaos. Now in that chaos we want to introduce, I mean you have to introduce the real world scenarios. So let's say you have a web application, and there are like the API requests are coming in, the requests are coming in. What happens if suddenly the request goes to 10,000, 12,000? That happens in e-commerce, very common use case. So you can actually test that, bursts of request. What happens when one of the pod that you're running in Kubernetes cluster goes down? What happens when the network goes down? There are some host chaos as well, where you can have your network failures, all these things. So those real world scenarios, load testing and stuff, we'll add those variable to the hypothesis. Then disprove the hypothesis. Now what we are trying to achieve here is, we are trying to disprove the hypothesis. If we cannot disprove the hypothesis, that means our systems are solid. Steady state remains constant. If the steady state that we defined in the first step remains constant, that means our system is perfect. Now we have to keep on trying and introduce chaos at regular intervals, so that our steady state remains the same. And if we disprove the hypothesis, then there is a scope of improvement. Then there is a scope that we need to improve the system. We need to do something. We found the bug. We need to fix the bug. And on the right hand side, if you see, you can okay, let's complete this first. So then we want this to run continuously. We don't want the chaos to be run just once. We want the chaos to be run in a continuous manner. And we also want to minimize the blast radius. Now this is very important. You want to run chaos engineering in production. You cannot afford to have a chaos engineering running in production and disrupting everything, impacting your business. So you have to carefully choose the specific namespaces, pods, node selectors where it will be happening, so that you can mimic the production stuff, but you also don't want to disrupt completely. So that is how you have to kind of take care of the blast radius, which is very important and critical piece. On the right hand side, you can see chaos engineering principle applies at all levels: infrastructure level, then Kubernetes level, cloud native services that you will be deploying on top of that, and then the applications, the real applications that your consumers, customers are using, or you yourself are using. So that is how chaos engineering works. These are the principles of chaos engineering. Now in these principles, and following these principles, following the cloud native ways, there have been tools that have been evolved, and two of them that we'll be discussing today is um, chaos mesh and litmus chaos. So very interesting tool, solid community. So let's discuss those. So chaos mesh is a chaos tool for Kubernetes. It has like a lot of cool features, like core capabilities out of the box, a lot of fault simulation scenarios like pod chaos, network chaos, DNS, HTTP, stress. It has also platform specific chaos like the JVM one, and in the UI also I'll show you what are the platform specific on the host. Obviously there has to be another agent on the host that has to perform these chaos, but they're there. Flexible experiment, you can upload your own experiment. That is something very interesting, because not everything will be available for all scenarios. If you have a custom scenario, you can create your own chaos. Active community, yes, they are on the Slack, as you can see of Slack. So very active community, readily answering the questions. Dashboard for analytics, it's very important. The observability, what happened during the duration of the chaos, what were the events that happened during the duration of the chaos. Workflows, which is very important, a set of combining the set of chaos experiments to create a complete workflow, and running the workflow on specific intervals or triggers. Again, it's super cool. So how it actually works. So when you install chaos mesh on the particular system, on basically on Kubernetes cluster, what will happen is a user will be creating the chaos experiment. So how the user will create the chaos experiment or the fault event is by the kubectl, the CR, the custom resource that I was talking about, or the UI. I think the UI is the most easiest and the most stable way of doing of creating the experiments. Then the controller manager, as soon as the controller manager will be having the custom resource notified by the API server, it will go and talk to the chaos daemon. Now, chaos daemon is a daemon set which is present on all the nodes. So chaos daemon is a daemon set that is present on all the nodes, and it is the one who is going to inject the failures, identify the network namespaces, and creating injecting the right chaos to the right pod of a particular namespace based on what you have defined. Like, you might have defined a node selector, you might have defined tons of other stuff. So it will take care of all those and create the actual experiment, run that. Then it will get the result of this and give back, so that you have, like, what was the overall result of this particular chaos. Then you can observe that, see the events and stuff like that. So that is how the chaos mesh looks like architecture wise. um, we what we'll do is, I will show you Litmus as well now. I mean, explain you Litmus now, and we'll see both chaos mesh and Litmus in the end. So this is Litmus Chaos. Litmus Chaos has improved a lot from 1.x to 2.x. I mean, they have now Teams collaboration, so you can have multiple users. I think that's dope feature. You can actually have multiple clusters, so it has actually gone multi-tenant. You can install the Chaos agents on multiple Kubernetes clusters, and you can subscribe to the Chaos workflows. You can enable GitOps. So let's say you have Flux or Argo deployed onto your cluster, or you have a repository, you can add annotation over there, subscribe to a particular workflow based on the workflow ID, and whenever there is a change, there will be the workflow will be triggered. I think that is what we are looking for. That is the integration that we are looking for with respect to chaos engineering. Everything is in Git. Anything changes, I have GitOps enabled chaos experiments, and also my chaos experiments like will be living inside Git. So I can have them in Git, so you have a single source of truth for everything. So observability, so you can bring your own data source. You can plug in the data source, create the fancy Grafana dashboards. So private and public chaos hubs. So I think they have grown tremendously with the set of features that they have brought with 2.x. So that is why there was a need. The shift has happened in the cloud native way of doing things, in the Kubernetes way of doing things. And let's see. So it has different custom resources. First is the chaos experiments, which is the pre-built templates that you can directly use from the chaos center. And you can also bring your own chaos. When you bring your own chaos, you can define, what container image you want to use, what are the different set of permissions that you want to use with respect to that chaos. So I think you can, do all sorts of things. Then you have chaos engine. So chaos engine is used to override the parameters that are coming from the chaos experiment, and also it binds the app instance to the fault. So this is your application instance. The chaos engine will be binding that to the fault, and here you will be defining the steady state or the hypothesis, what will be happening, what does your steady state looks like, so that your results look like that. You'll be also defining the node selectors, the namespace, the service account which you want to use, defining the runtime characteristics, how this will be run. So all these things goes into the chaos engine, and chaos results are basically the success criteria measurement that holds the results of the chaos experiment with the names space scope. And so the shift was very obvious, like why they went. So these are like from 1.x to 2.x. So there were experiments. Now we have experiments plus workflows. You can have a complete end-to-end workflow that you can run. It was per user, it is multi-tenant. I think this is super awesome feature. Per cluster, it is per organization. You can have different projects, and you can have different clusters, chaos agents, very easily connected using Litmus Cuttle, which is, or Litmus CTL, whatever you want to call. So you can just use Litmus CTL agent, define the endpoint, give the agent name, and that will be connected to the particular Litmus hub. Chaos center. And you can have public private chaos now. Earlier it was only CLI, now it has a fancy GUI, and you love that. When I'll show you GitOps, I already told you this use case. So it has GitOps enabled, very scalable and integrated and interleaved monitoring. We can also see that. I think it is already there in the dashboard, but even if you want more, you can add your data source and get all the things. This one last thing before we move to the okay, two things. So let's see the workflow, how like we saw the whole what you call chaos mesh workflow. So now let us look at the Litmus architecture. So you have two things, which is the control plane and the execution plane. So control plane is the actual chaos center, the actual UI and the UI components for managing that. So you are having a MongoDB for storing the chaos experiments and storing all the configuration past results and stuff like that. Obviously the authentication is for auth server is there. GraphQL server is the Golang microservice that is there to do all the pass all the queries here and there to the execution plane, get stuff back from the execution plane, and you will be interacting with that chaos center using the UI, and you can then it goes to the execution plane. When it goes to the execution plane, you will be having you are having the chaos experiment CR and the chaos engine. So that is what that is actually actually running the chaos with respect to the microservices that you have defined. So if it's a workflow, it will run one after the other or parallel. If it's subscriber type, so you can also subscribe to those agents, then also it will kind of trigger the same chaos workflow, so that the controller takes care of that. So you have the chaos Litmus chaos controller that will be taking care of all these things, and creating the custom resources of chaos engine and experiment, and then giving back the result to the chaos center so that you can observe the results. And yeah, I think that's pretty much it. Yeah, event tracker, you can also subscribe, and yeah, they have some specific chaos to clouds as well. So they are expanding on those, where they are expanding to bare metal and cloud services, providing exclusive chaoses with respect to the cloud vendors, which is again interesting thing, because everything is moving cloud. That is why I told, like, it's a cloud native and Kubernetes way of doing things, and you have to go this way. That is why, like, both the tools and even others, they are evolving in a similar manner, solving the same kind of challenges, and now it's up to the kind of use cases which one you want to adopt. Cool. Let's move to the next slide. Demo. Okay. Cool. We have the demo. Let me stop share and reshare the screen. And I have to, I think, share the entire screen. Sorry for that. So I already have two Civo Kubernetes cluster. So if you don't know Civo, Civo is a managed Kubernetes provider, which is based on K3s. And these are two of the clusters that were provisioned, which is Chaos Mesh, and the other one is this one. So you can see, we'll just go through. I just want to show you the components actually. Kubectl get -a. So if you see in the chaos testing namespace, so the installation is pretty simple. Both Litmus and Chaos Mesh I have installed using Helm. So the installations are pretty simple on their documentation. You can install using Helm, and for Chaos Mesh there is a special installation for K3s that is there. So you can use that. The flag is there, so definitely use that. So you can see the daemon is there. So I told you chaos daemon will be running on all the nodes. So you have three worker nodes. It is running over there. You have the controller managers, which is working. You have chaos dashboard, which we'll be seeing. So you already have that. Let's see, get namespace. So kubectl get pods. Actually, we can just look at the Litmus namespace. uh, Litmus. So you can see, actually I have already run a chaos, so that's why this is the chaos that has already run and is completed. But you have an event tracker, you have chaos exporter exporting the metrics. This is the MongoDB that I was talking about. The operator is there, the subscriber is there, the workflow controller, then you have the server and the front end. So all these components are there from the control plane and the execution plane, which are deployed. Let's look at the UIs. So this is how the chaos center looks like. So Litmus Chaos Center, and you can see in the settings that I have, this is my account, and I think in the team only one user will be there at the moment and one project. So you can see the member, you can invite a new member. So that's how you can do user management, and you can connect to a Git repository to enable GitOps. So you can use that, provide the Git URL branch token, and you can connect to that for to enable GitOps, so that everything is stored over there. And you can even subscribe to the workflows then. Then you have the image registry for the workflow manifest if you want to use. Let's look at the workflows. So these are the workflows. So if you see, I can schedule a workflow, then I have to select the agent. So when you install Chaos, Litmus Chaos, it will pre-install the self agent, but you can install using the Litmus CTL the other agents as well. Like you have, I think, Litmus Cuttle. You can have a Litmus Cuttle create agent, and then you can define the agent name, and you can also do the project interactive way and the non-interactive way by providing all the details in a single string. Then you select the agent, and you go next. You select from chaos hubs or select from predefined workflows. I already ran potato head, so I can run the different one. You can go to next, and you can define that you can tune the workflow, edit the sequence. So this is the sequence, this is all will be performed. If you want, you can edit this particular workflow, edit the YAML, and you can click next. You can this is the uh, weightage of the experiments per experiment that you want to do, like a CPU memory, delete the points related to that. And then you have the schedule. So you want recurring schedule, like I was saying, the continuous portion of it, we need to run it continuously, it cannot be run just once. So whether you want to run continuous, we want to schedule now, we say schedule now, verify and commit. You can see everything and you can finish. That's it, you have successfully gone and created the workflow, it is now running. So if you see the already run workflow, you can see all the steps that happened. You can go over there and you can see what happened, what was the start time, end time, target, and all those things. You can view it as a table view. You can view the chaos hub. So this is the Litmus Chaos hub. You can definitely see the observability. You can see the workflow statistics, and you can see how it ran, what happened during that, how many runs have happened. You can see the usage statistics, like one user, one project, what is the overall usage of this particular chaos center. And yeah, I think that's interesting, all these things. And you can in observability, you can also plug in your own data source, and you can create more fancy dashboards. Let's quickly look at the chaos mesh as well. This is the chaos mesh dashboard, and yeah, this is the overall experiment, schedules, workflows. I've already run one experiment. You can see the workflows are here. I can create a new workflow. I can create a single workflow, serial workflow, where I can add different tasks, want to run serially, or I can add parallel tasks. And for each parallel task, it's actually an experiment which is there that I have to define. Now if I go to the experiments, I can create a new experiment. Now it can be Kubernetes based or it can be host based, like I was telling you. So if Kubernetes based, it has AWS experiment, GCP, IO injection, network attack, stress test. Now if I click on there, I have to define some of the parameters. Then the scope of that, very important, which namespace, which particular label selectors or specific pods I want to run, for how much time I want to run this, and I can click on submit. So I think that's pretty interesting. You have pre-built experiments, and also I think there is option to load from, so you can load your own load by YAML or the experiment that you want. uh, and this is the experiment that I already ran. So you can see this was the stress chaos that was applied to the cluster. So it tells you, like, this is what that has been applied to the cluster. This is how it actually ran. So it's a series of events that happened, and you can also see these events in under the event section. So you can see what all things happened, applied the chaos testing, recovering, what all things already happened, and then updating the records. And they also go to the I think archive. Yeah, you can archive the experiments as well. So you can go and you can click on archive, so it goes here. And again, some general settings, if you want to enable cube system namespace for running the workflows or the experiments. So pretty neat and pretty simple actually, because you this is where you upload the experiment as well. So this is pretty simple. And the chaos center one, they have like much more powerful, because it provides like user management, team management, and the multi-tenant are really powerful features, in my opinion. So last point that I want to make is, since everything is going cloud native, now people are coming together to create a white paper. And the focus of the white paper is, the chaos engineering group is there, which is already have written the white paper. It is not yet published. It is going through a number of iterations from various tags in CNCF. So it defines like introduction to chaos engineering agreed by both the parties. And the what you call glossary, the chaos engineering glossary, evolution in the cloud native landscape, which I explained you, general tips to get started for beginners, survey open source projects in CNCF landscape to see like security related and stuff, how they can evolve and contribute together. Chaos implementation from end user, very important, so that everyone can learn how other users are running the chaos engineering tools in production, and you can follow the similar pattern, or you can learn from them. Future of chaos engineering with emerging trends, like with respect to security monitoring, like ebpf, what all things can be done, if it can be done. So future of chaos engineering, so all the chaos mesh and litmus and some of the other parties have come together, forming this white paper, agreeing that we are moving towards a common goal of solving chaos engineering challenges in the CNCF landscape, and moving towards a single white paper and single goal in different manners. That's pretty much it that I had for you. Thank you so much for tuning into the talk. And yep, I'll stop sharing the screen. I hope you enjoyed the session. And I think you got some gist on chaos engineering, and what it is, and what are different tools and what they do.
Okay. Thanks, Sam. This was, I think, a very great presentation. I hope like everyone would have learned a lot from this session. I think we have some questions here. Maybe we can take some questions here.
Yep.
So also, we are there are some good upwards we are getting on the questions. So we can take first question. I'm just taking it on the stage as well. So this was the first question. Can an agent only run one experiment at a time? And like, what is the best approach to run experiments in parallel? This is from Tarun Khosla.
Yeah, I think there was the option I showed to run experiments in parallel. So you can run them serially or parallelly.
Okay. I hope, Tarun, this answered your question. Um, okay. Let me take another one. So there is one more question. This is from P. Gokul. So is there a roadmap for chaos engineering, like your DevOps roadmap for people starting from scratch?
So basically, this was from scratch. What I told you. If you want a deeper dive session, then Karthik, who is the maintainer of Litmus, Karthik will be doing a great session on the deep dive, some of the other stuffs. Definitely check that out. But I think this one was from scratch, because I told you the evolution of chaos engineering, what it is, the principles, then some of the toolings and challenges they are trying to solve. I do have a couple of videos on my YouTube. You can check on both the projects, even the deep dives. And if you want further like roadmap, would be just get involved with the working group, see what both the parties and other people are working towards a common goal.
Okay, great. Let me take next question. So this is from Amit Das. So what is the future of chaos engineering, and can this be used as a long-term solution?
Oh, yes, chaos engineering practice, like I told you, is there from a long time. It is now even more important with respect to the number of outages and failures that are happening. Yeah, I didn't cover extensively why chaos engineering, but you can see the amount of outages that are happening with respect to the all the systems, all the applications. They have increased over time, and I think there is a lot of scope in bringing them down by using the chaos engineering in production. And there are some security stuff that are happening. I think chaos engineering, like someone was asking the roadmap, so they are working with the security teams to understand the security landscape, how the policies can be implemented, how the some of the additional checks can be happen, so that there can be some security related chaos as well created in future, and we can avoid some security vulnerabilities or to your clusters and application as well.
Okay. Okay. So yeah, these were all questions from our attendees, and I'm seeing that the feed is completely filled with very nice and very good answers and chats. So I hope everyone enjoyed it, and I think this was a very great session. I hope that everyone must have learned a lot from this session. So yeah, thanks everyone for joining in, and there are some more sessions coming in next up. There is a swag pool also in the next meeting, so you can join that as well. And yeah, thank you all for joining. Yeah,
Thank you
okay,
all. Bye.
thank you. Bye bye.